In this demonstration, we show how a flasher circuit is operated in TINA using the PIC microcontroller. We also show how to use the built-in debugger, generate a PCB, and finally test the circuit in 3D. First, we open the circuit, which is found in TINA's PCB folder. This is the circuit. Let's see how it works. We start the interactive VHDL simulation and see that the LEDs are flashing from bottom to top. The direction of the flashing can be changed by clicking the first position on the dip switch. Now we click again, and the LEDs are once more flashing from bottom to top. This circuit operates by running a microcode in the microcontroller. Let's look at the code to see how it works. We double-click on the microcontroller and click on the last line in the Properties box. Here we can view or edit the assembly code running inside the controller. While it is possible to use TINA's built-in debugger to make the changes, and run the code again in its entirety, it is also possible to run the code step by step, or even make a breakpoint. Now let's see how to use TINA's MCU debugger. First of all, make sure the VHD button of the interactive mode is switched off. Next, enable the MCU debugger from the analysis dialog. Click on the Enable MCU Code Debugger checkbox and press OK. Note that in the newer versions of TINA, you can enable the MCU debugger directly from the analysis menu. Pressing the VHD Interactive button, the MCU debugger window appears. Let's move it to another position so that we can also see the LEDs. We click the Trace Into button to follow the program operation step by step and see the registers and memory locations at the bottom of the screen. We can also run the program and see the results of the operation. In our case, we can see the LED flashing from bottom to top. Note that the flash changes direction when we click the dip switch. We halt the debugger with the Stop button. Of course, this program can be run either step by step or using the breakpoint option. Let's place a breakpoint at the increment label. We position the cursor after the label and then press the Toggle Breakpoint button to insert the breakpoint. Now let's click the dip switch again in order to use the incremental mode. Where the LEDs are flashing from bottom to top. We start the program again with the Run button. Now we see the program running, and as soon as it reaches our breakpoint, it will stop, and we can check the registers and memory locations. From here, we can either continue step by step using the Trace Into button, or click Run to continue the operation. Again, of course, the program will stop at the increment label. Let's close the debugger now. Before building the actual circuit, we will see how to visualize the circuit on the PCB. We generate a 3D working prototype of the circuit using Tina's PCB designer. First, click on the PCB Design button on the toolbar. The PCB Design dialog will appear. The PCB layout for this circuit has already been designed. So we only have to click OK to bring up the layout. This is a two-sided PCB board. We will now describe the 3D virtual prototype, but not discuss the details of the PCB design. To generate the 3D prototype of the circuit, we have only to click on the 3D View button on the toolbar. The 3D view of the circuit appears as a new window. Using the arrow keys on the keyboard, the circuit can be rotated in any direction. For example, press the up arrow to examine the wiring on the bottom of the circuit. We can also rotate the circuit by holding down the left mouse button and moving the mouse. Also, we can zoom in and out by holding down the right mouse button and moving the mouse. Or simply using the page up and page down buttons on the keyboard. Now let's switch back to the schematic editor by clicking on the Tina button at the bottom of the screen, or by pressing Alt-Tab. If we click the VHD Interactive Mode button on the toolbar, the circuit begins to function. We can see that the LEDs are flashing not only on the schematic, but also on the 3D model. We can also try out the dip switches. For example, clicking on the first switch on the bank to change the direction of the flashing. We see that using Tina, it is possible to test every aspect of a circuit before manufacturing using the working virtual prototype. Finally, let's compare our 3D virtual prototype with the real circuit. Based on the files generated by Tina, we have manufactured the circuit tested here. This circuit appears in the video at the bottom right corner of the screen. As we can see, its appearance and operation is very similar to that of the virtual model. Just as with the virtual model, you can change the direction of the flashing with a dip switch. The circuit works just as we have designed. This concludes our demonstration of using TINA for designing, testing, and building MCU circuits.